So here's a good question for you. If you drop an object in the absence of air resistance, it accelerates downward at 9.8 meters per second squared, right, on Earth. By the way, that's an average value, right? That assumes that the Earth is a perfect sphere, which it's not, okay? So, you know, this is average over the entire planet, this 9.8. Anyway, if instead you throw it downward, its downward acceleration after release is what? So pause your video and answer that question, please. Okay, so I already demonstrated this, right? As soon as you let go, what's the only force acting on it? Gravity. So therefore, what's the answer? 9.8 meters per second squared, right? As soon as you release it, you don't have any more influence on it. It's just gravity. Okay, throw a ball straight up. Which of the following graphs correctly represents the motion? Now, just a hint. Whenever you get a question like this, the first thing you want to do is see, wow, what kind of graph is it? Is it X versus T, V versus T, A versus T? What? You gotta figure that out. Okay, so this is throwing a ball straight up. All right, so pause your video and figure it out. And this is up, not down. Okay. Well, actually, I lied. It's up and down. So up and down. Okay, so this is just free fall, right? The acceleration is a constant minus 9.8 meters per second squared. So, you know, this is nuts, right? This shows that the velocity gets smaller. That makes sense, it goes to zero. But does the velocity get bigger in a positive way? No, that's crazy. Okay? This is crazy for the same reason, right? This is always negative. That doesn't make any sense. This here, it starts out negative. That's crazy. You're throwing it up. It's positive. And also, look, the acceleration is constant. Should be straight line. Should be straight line. Now this is a positive slope. It can't be a positive slope. The acceleration to the gravity is minus 9.8 meters per second squared. This is the only one that makes sense, right? You start off with a positive velocity. It gets slower, 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 slower. It stops. Then it gets faster, faster, faster. But it's constantly, but the acceleration due to gravity is negative. So it's that one. Okay, one more. Throw a ball straight up. Which of the following graphs correctly represents the motion? Now you're going to read what that is. It's A versus T, right? So pause your video and figure it out. What was that? I don't know. Okay, well, let's do it. The acceleration is negative 9.8 meters per second squared. So this is the T axis. So here, that's crazy, acceleration doesn't change. This is crazy, acceleration doesn't change. This is crazy, acceleration is not positive. Here's the T graph, acceleration is negative, and that's constant, right? Minus 9.8 meters per second squared. So it's that one. Okay, now this here, position versus time. So what I'd like you to do is rank the speeds. Now notice I didn't say velocities. I said speed. Speed is absolute value of velocity. So figure out the speeds for A, B, and C and rank them. Fastest to slowest. So pause your video and figure it out. Okay, so let's see. What's the speed here? It's the slope. Well, the slope is 6 meters divided by 1 second. So the velocity at for segment A is the speed at segment A is 6 meters per second. All right, what is the slope for B? Well, it goes from here to here. So 6 minus 4, or actually 4 minus 6, right? So the velocity, but we care about speed, so I don't care about the direction. So the velocity, the speed at B, the change in y is 2 meters, right? Right, that's 2. The time is 2 seconds. So it's 1 meter per second, right? And then for C, what's the speed at C? The slope is 0, right? 0. So the speed at c, it's not moving, right? It's not moving, so it's 0. So A is fastest, then B, then C, right? So A, then B, then C. If we were in class, I usually have a student demonstrate this. It's kind of fun, right? And so what they have to do, they have to go to the right really fast. Then they have to go to the for 1 second, right? They go to the right for 1 second really fast. Then they go for 2 seconds to the left really slowly, and then they just stay put for a second, right? That's what it means. So you should be able to, when you see a graph like this, you got to be able to say what's actually happening in the real world, okay? What's going on, what's the motion, all right? Okay, now what I'd like you to do is, well, I already said it. Forget it. Waste of time. Okay, so this is what the velocity would look like, right? So the velocity is 6 meters per second for the first second. And then for B, from 1 to 3, it's 1. Oh, this is velocity, not just, okay, so remember it was negative. So it's -1, and then it's 0 right there. Okay. What's this line doing here? Seems like a stupid place to put a line. Whatever. All right, so there you go. Okay, now we said that we were going to do problems, right? So there you go. These are the equations. So these are called the one-dimensional kinematic equations for constant acceleration. So notice, we've been talking about free fall. What's so great about free fall? It's constant acceleration. Why do we care about constant acceleration? That's why, right? So these equations are only good for constant acceleration. Now, I will give you all of the equations for the test, except for these 3. You have to memorize these 3. Why do you have to memorize these 3? Because it's going to help you later on. Trust me. Because first we're going to do one-dimensional kinematics. Then we're going to do two-dimensional. And guess what? Two-dimensional is just this in 2 dimensions. Then we're going to do circular. And all of the equations are similar to this. So believe it or not, if you just know these 3, it makes later on easy. It really, really does. So just memorize them, okay? Just memorize them. And you got to be careful too, though. Like what's this delta x? It's the displacement, right? So it's x final minus x initial. It's not the total distance. Remember we talked about that? It's the displacement. So just be careful. Just be careful with the signs and everything. Just be careful. Yeah, boy, you're going to see them again and again and again. I promise you that. All right. Oh, my goodness. Okay, so I'm just giving you this now. We're going to prove it later on, but I think you'll need it in a homework problem or something like that. So, free fall, a sub y equals minus g. Well, what if it's going down a slant? Then it's going to be different than minus 9.8 meters per second squared, right? So this is just an answer, right? We'll see why later. And y, so a is g sine theta, and it's plus or minus. Why plus or minus? Well, if we use this coordinate system, it's minus. Well, later on, right, you're going to see it's smarter to use this once in a while. So if you use that, it'd be plus. Okay, that's all. And let's see if this thing makes sense. Let's see if this makes sense. So we have a, I don't care about the sign, g sine theta, right? Okay, so let's say, and so here it is, right? There's theta. Okay, so let's say we make theta 90 degrees. Well, that's free fall, right? I mean, just falling straight down. Well, what's sine of 90? 1, so right? So it makes sense, right? Just a equals g. Now let's put it like this. So let's say this is 0 now, right? Well, if it's 0, what's the acceleration? It's not going to accelerate, right? Because what's the sine of 0? 0, okay? All I'm saying is the formula makes sense. All right. Oh, golly. So now what we want to do is we want to get some practice. We did the pictorial representations last time, but now in the previous chapter. Now we want to actually put it all together and solve some problems. All right, this is what it's all about, okay? We'll be doing this the entire rest of the semester. So you really got to know Chapter 2. All right, now one thing that I want to suggest to you, when you're doing a math problem, you always want to do the algebra first. You want to plug in the numbers at the very, very end. Okay? That's really, really important. And the reason is because sometimes when you do the algebra, things cancel, you know? And so there's less numbers to plug in. If you just plug in all the numbers, nothing cancels. I mean, you know, it's not as easy to see if it's going to cancel. So, anyway. And also, you know, it's easier to check your algebra with letters, you know, with variables than with numbers, right? So usually just wait till the bitter end to plug in your numbers. All right, here we go. Sally opens her parachute at an altitude of 1,500 meters. She then descends slowly to Earth at a steady speed of 5 meters per second. How long does it take her to reach the ground? Oh boy. Okay, well, what's the answer? I mean, you don't need to do any problems. You just do it in your head, right? I mean, 1,500 meters, 5 meters per second, you know, and we know that distance equals speed times time, right? Okay, so that means that distance over speed equals time. The distance is 1,500 meters. The speed, is 5 meters per second. That's 300 seconds, right? Right? And you can do that in your head, right? In fact, you didn't even need to do this, right? Come on. I mean, you have to admit, you know, you're experienced enough with life. I mean, 1,500 meters, 5 meters per second, 300 seconds. Okay. So this is a total waste of time, right? Wrong. We're just going to do it for practice, you know? We just want to get used to doing this kind of thing, all right? So here we go, okay? All right, so actually I would read it twice. Get in the habit of doing that. Read it twice, okay? Okay, step number 1, draw a coordinate system. So we're just going to use, you know, let's just use this now. This is people think, why do you do this all the time? It's stupid. It's a great thing because it just reminds you that up is positive and down is negative. And later on when these problems get complicated, it's going to help you. Okay, number 2, let's just do the motion diagram. Okay, so we start and we end. And why do we bother doing that? Because right away, man, A is 0, right? We know A is 0, so that's great. Okay, then we want to do the pictorial representation. How many points do we need? Just 2, beginning and the end. Nothing is changing, right? I mean, you know. All right. And so, you know, do what you always do, right? So what do you want to call the origin? Let's do that. Doesn't matter, though. So Y0, V0. We don't have to write A0 because we already know what that is, right? And then T0, and this is Y1, V1, T1. That's all you need. Okay, now you got to write everything, right? Okay, so what's Y0? Positive 1,500 meters. Okay, what's V0? Well, what's V0? That's where she opens it, right? So she's already moving, right? Now, here you've got to be careful. Here you're going to appreciate this. What's V0? 5 meters per second, right? Wrong, wrong. She's going down, right? Okay? So you got to put the minus. If you don't put the minus, you get the problem wrong. So honestly, this is a good thing. And T0, you know, we'll just call it 0. Why not? All right, then, okay, so we got that. Now we go here. So Y1 is 0. Why? Because we decided it was going to be 1. All right, now, how long does it take her to reach the ground? Well, what does that mean? Does that mean like after she hits the ground? Or, you know, what does it mean? So, in other words, what's the speed right here? So we talked about this before, right? This is an English thing. How long does it take her to reach the ground? So we're saying how long does it take her to reach the level of the ground? You know? So forget about the ground being there. How long does it take to reach the level of the ground? That means she's still moving at minus 5 meters per second. So V1 goes minus 5 meters per second. Or if you want to, you can say, how long does it take her to reach, 10 to the minus million meters before she hits the ground, right? So she's still moving. That's the important thing. She's still moving. And then, okay, so this is not 0, all right? That's the important thing. And then T1, we don't know, but in fact, that's what we want to know, right? Okay. All right, now you want to look at your equations, right? You have your 3 equations. Okay. Now, we want to know the time, right? And so, like the last equation doesn't even have a time. I mean, right? This doesn't even have a time. So we're certainly not going to use that one. That'd be super, not real smart, right? This one, there's a time, but A is 0. So that's not going to help us, right? That's not going to give us any information. It just says V final equals V initial. Well, duh. I already know that, right? So that's not going to help us. So see, that's what you got to do. You got 3 equations. You have to choose the right one. Okay, so that won't help us. That won't help us. It's better, right? That's all we have left. And I'm going to write y instead of x just because I feel like it, because y is like this way, x is like that way, Okay, so, when you're doing this, you're going to skip steps, but I'm not going to right now. I'm just going to show all its glory, all right? I'm going to do it as slow as possible, okay? So here's the equation. So y final equals y initial plus v initial y delta t plus 1/2 a delta t squared. All right, there it is, right? Oops, sorry, right there. I guess I didn't have to put a y there. Who cares? I'll get rid of it. All right? All right, now, what does that mean? This is what it means. Y final equals y initial delta t. What's delta t? T final minus t initial, right? Plus 1/2 a t final minus t initial squared. Okay, now I'm wasting time, I know it, but that's what I just wanted you to make sure that's what it really means. All right, that's what it means. Okay, now we don't have to do all that. Good golly. Okay, so what I usually do at this point, I usually put in everything that's 0. Okay, well, first of all, let's change the subscripts. So final is 1, initial is 0. I would have written that first, but I just wanted to show you. Okay, so what I would do now, anything that's 0, I cross out. So what's 0? Time initial. So goodbye, goodbye. What else is 0? A, goodbye. What else is 0? Y. Uh-oh, what did I do wrong? Oh, what did I do wrong? Oh, I forgot the V. Oh, golly. Sorry, I forgot the V. I forgot this part. So plus V initial, T final minus T initial. I'm just going to, that's 0. Let's forget about it, okay? All right. So T, this is T1. That's T0. That's 0. Okay, so there I go. Now what else is 0? Y1 is 0. So I have 0, right? That's 0. 0 equals Y0 T1 plus V initial, which is what? V0 T1. Okay? What? What am I doing? I know what okay, let's just start over, huh? Let's just start over. So forget about the last 2 minutes. All right, here we go. Y1 equals, right, because it's the final, equals Y initial, Y0 plus V initial delta T plus 1/2 A delta T squared. Golly. All right. What's delta T? T final, which is T1, minus T initial, which is 0. So just T1. T1. That's what it usually is, Okay. Now let's put in our zeros. What's 0? Y1 is 0. So we have 0. All right. Remember, algebra first, numbers last. So V0 T1 A is 0, so I don't have to write that, right? I don't really have to write that. So there, that's what I'm calling. Right, that's 0, that's 0. Okay, so there it is. Yippee! So what am I supposed to get? I don't even have to read the problem. I get it circled. Isn't that awesome? So I just solve for T1. So minus y0 equals v0 T1. So T1 equals minus y0 over v0. Okay, now look at everything I need is right in front of my face. So y0, where are you? Right there. So it's minus 1,500 meters. And v0 right there, minus 5 meters per second. You do that, a minus over minus is a plus. You get 300, what? 300 seconds, right? Because a meter over meter per second is a second. So you always want to write the units because it will help you, it will prevent mistakes, okay? All right, now, is this reasonable? Yeah, I mean, yeah, right, it's reasonable. I mean, if you get like 3 million or 0.0003, it's ridiculous, right? So you always want to ask yourself, is it the right units and is it reasonable? Okay, so there you go, all right? Sorry for my goofing around. Okay, so coordinate system, motion diagram, just gets your brain cells going, you know? Pictorial representation, position, velocity, acceleration, time for every point. And then you have to define every single point. You're either going to have a number, a value, or a question mark. Then the way I do it, I circle what I want. Then you just go and you look at the equations. And one of these is always going to work. But you've got to pick the right one. I mean, that's the important thing, you know? You've got to pick the right one. You just got to look at them, see which is the right one. And then you just do it. I mean, you got to admit, this algebra is pretty simple, right? So you write the equation in terms of the variables. Then what I do is I put in my zeros. You don't have to do whatever you want to do, but just do the algebra first, you know? Do the algebra, and plug in your numbers. Yeah, you can get the right answer. Okay? And look at, if you did something goofy, like if you forgot this minus sign, you know, then you'd come over here and you get minus 300 seconds. What's that mean? You know what I mean? So just got to watch those signs. All right. This is just this is just a review. Yeah, you got to know this, golly, right? A sub y minus g minus 9.8. Okay, we went through all this stuff. Yeah. Okay, let's do another. All right. So this was a silly question, right? Because we do it in our heads. Let's do one that's not so silly. So everybody read that, please. All right. Bob throws a ball straight up, 20 meters per second, releasing the ball 1.5 meters above the ground. What's the maximum height? What's the ball's speed as it hits the ground? Now again, as it hits the ground, it means, just barely before it hits the ground, right? So that's what they mean by that. Okay, whoa, here we go. Coordinate system. And I'm not drawing this because I don't care. It's only an up or down problem, right? Okay, motion diagram slows down, speeds up. So, however you want to do it. All right, and you got to do it like that, right? Because it starts, here and ends on the floor. So this is the start, and this is the end. Okay? Now, wait a second, this is free fall, right? So what's the acceleration? So A equals minus g. Okay, awesome. Okay, now, how many points? How many points do we need? Well, we got a beginning and an end, but what else? We want to know the height, right? We want to know the height. Well, that's up here. So we have to have 3 points, right? We have to have 3 points. Okay, so let's say that's the ground. So 3 points. All right, no problem. So 1. Okay, so look, this is the same as that, okay? It just, I don't want to, it just makes it easier. So, all right, so y0, v0, t0, y1, v1, t1, y2, v2, t2. Okay? So where do you want to put the origin? It's up to you. You could put it here, you could put it here, you could put it here, whatever you want. But I'm sort of boring, so I'm going to put it there. All right. Okay? By the way, let me just think for a second. Here, it's going at 20 meters per second, and it's free fall. So what does it have to be here? It has to be more than 20 meters per second, right? Remember we talked about that? In fact, right here, it's going to be 20 meters per second. So all I'm saying is it better be bigger than 20 meters per second or else we're wrong. Okay? So you always want to keep stuff like that in your head, Because, if you get like 10, how do you know it's wrong? Unless you remember this free fall stuff, So it better be greater than 20. All right, here we go. Oh my gosh, this is going to take a long time. All right, so here, so y0 equals 1.5 meters. Velocity 0 is 20 meters per second. And time 0 is 0. Okay, up here, y1 is what we want, right? That's what we want. So we want to find the height. What's the velocity here? They don't tell us. What is it? It's 0, right? It stops. It's a turning point. So v1 equals 0. And what's t1? Do we know t1? We do not know t1. All right, no problem. Okay, now here, y2, that's the ground, so it's 0. Okay, v2 is what we want to find also. And t2, we don't know either. Woohoo! All right. Wow. All right, there you go. So let's find the height. Let's find y1. y1. Okay? So here's the equations, right? Now let me get them big. Yeah. Okay. So look, we want to get y1, right? The height. Now, we don't know the time, right? So that's kind of a problem. So we can't use that because there's a time. Can't use that because there's a time. So let's see, can we use that one? Well, let's see. Let's see, V final at the top is 0. We know V initial, right? We know V0 here. A is the acceleration due to gravity, so there it is, delta x, right? Or delta y. So that's the one we're going to use. All right, so that's the one we're going to use. Okay, so again, it was V final squared equals V initial squared plus 2a, I'll say delta y, okay? So there it is, all right? Now, and again, this is just 1, this is just 0. Pretty soon, you're just going to be writing this automatically, okay? All right, okay, and what's this delta y? Going to be a little careful here, right? It's y final minus y initial. So it's y final, y1 minus y initial, which is y0, right? Right? This here to here, Okay, so what is 0? What is 0? Well, v1 is 0. By the way, once I have this written, I don't even need to refer to this anymore. I don't care. It's out of the way. In fact, let's just get rid of it. All right, let's just look at our equations. Okay, so this is everything I need. So v1 is 0. All right. Okay, now what am I solving for a y1? Okay, so let's do it. So we have 0 equals v0 squared plus 2a y1 minus 2a y0, right? Okay, now I'm trying to solve for y1, so I got to get this over here and that over there. So I have 2ay0 minus v0 squared equals 2ay1. And then I want to get y1, so I divide by the 2a, divide by the 2a. I did it right, what do you know? Okay, all right? Now I just plug in the numbers. Okay, we can do that. So 2, okay, what's a sub y? Minus 9.8 meters per second squared. Okay, 2a y0, what's y0? 1.5 meters. Okay, minus v0 squared, minus 20 meters per second squared, all over 2. A is minus 9.8 meters per second squared. All right, so there it is. Make sure you get all those minus signs. I promise you when you do it, you get 21.9 meters. Okay, so it goes up 21.9 meters. Now, does that make sense? I mean, let's put it this way. Is it reasonable? Well, first of all, we got the right unit, right? Because we have meters per second squared on top, and we have meters per, we have what? Yeah, this is fine. So we have meters per second squared on the top, but we have meters squared, golly. Meters squared per second squared on the top, but we have meters per second squared on the bottom, so we're just going to get a meter, right? Okay, so we have the right units. This seems reasonable. It's not a million, it's not 0.001, it's reasonable, right? So we believe it. Okay, so we got it. So y1 is 21.9. 21.9 meters. Okay, awesome. But we're not done yet. Now what we want to do is we want to find v2, right? We want to find the speed right before it hits the ground. Okay, now, again, look, I don't know what time, right? So this is the equation we're going to use, right? This one. Now here's the question, though. All right, so we know that V final is going to be V2, but what's V initial going to be? Is it going to be V1 or is it going to be V0? Well, actually, come on, laws of physics, right? It doesn't matter. It doesn't matter at all. You get to choose, okay? It just doesn't really matter. So I think if it were me, I would probably say that the final point is this, and the initial point is that. So I would just worry about this part. That's what I would do probably. But just to be weird, let's say that the initial point is this, all right? Let's just do it, okay? Well, just why not? So we're going to say this is the final point, and that's the initial point. It will work, all right? I guarantee you it will work. All right, so here we go. So we want, so V final squared equals V initial squared plus 2a delta y, right? Okay, now, final I said is 2, initial I said is 0, just to be weird, and delta y would be y2 minus y0, right? Okay, all right, now, anything 0? Yeah, y2 is 0, awesome, right? Okay, so we have v2 squared equals v0 squared plus 2a y2, right? Because v0 is 0. I mean, y2, come on. y2 is 0, okay? All right. Now, wait a second. What's going on here? Oh, I made a mistake. Sorry. Golly, I'm having a bad day. y2 minus y0. y2 is 0, right? y2 is 0. So I get a minus y0. Agree? Yeah, much better. And that's, I can just write that as a minus sign here with a y0. Yeah, much better. Okay, now I want to get v2. So I got to take square root. So v2 equals plus or minus square root v0 squared minus 2ay0. Now, what's with the plus or minus? Well, you know, when you take the square root of both sides, you got to take plus or minus, right? Okay, so you have to choose. Well, come on, it's going this way, so what's the sign? Minus. So you got to do that, all right? You have to do that. All right, so then you just plug it in. Okay, V0, where are you? 20. 20 meters per second squared minus 2a, somewhere I wrote it, minus 9.8 meters per second squared. Y0, where is that? 1.5. 1.5 meters. And I promise, oh, wait a minute. What? Oh, yeah, I'm good. Yeah, okay. And when you do that, you get minus 20.7 meters per second. Now, remember what we talked about. We said that he threw it up at 20, and we wanted to know what it was before it hit the ground. And we said it had to be bigger than 20. Is it bigger than 20? Magnitude? Yes, it is. So we believe it. All right, now notice something. When we had to solve for the maximum height, we just solved for it, right? We didn't have to solve for anything else. We just solved for it. When we wanted to get the impact speed, V2, we just solved for it. That's not usually going to be how it is. Usually, you're going to want to find something, but in order to do that, you got to find something else. Okay, so we're doing these nice, simple examples. It's going to be much more difficult. Okay, let's quit. Oh boy.